Hey everyone, today we're going to learn about Riemann sums. This integral right here is asking us to find the area under the curve 4x minus x squared. Now normally we would have to do this with an integral, but using the Riemann sums method, we're able to use this equation to take aspects of this curve and turn them into rectangles so we can more easily find the area under the curve. So the first thing we're going to do is find our n. So n is going to be the number of rectangles we make here. So the easiest one for here is n equals 4, because we can split the curve into 4 equal sections. The second thing you're going to do is find delta x. Delta x equals the largest number in your range divided by your n. In this case, we would get 4 over 4, which is equal to 1. The third thing you're going to want to do is draw your rectangles, like so. The last thing you're going to do is you're going to use this equation to find the area of all of these rectangles and add them together. Today we're going to be going over 3 types of Riemann sums. The first one is right-hand sum. As we previously established, the first thing we're going to do is find our n value. And just like before, we can say n equals 4. And then we have to find delta x. And just like before, delta x equals 1. And now, because this is a right-hand sum, we're going to use the right 4 rectangles to compute the height of the rectangles. As we can see here, the y value for 1 is 3, the y value for 2 is 4, the y value for 3 is 3, and the y value for 4 is 0. So now, if we look back at this equation and plug in our new information, we get this. So now let's plug in our values. After plugging in all of our numbers, we find that the first rectangle has an area of 3, the second rectangle has an area of 4, the third rectangle has an area of 3, and the last rectangle has an area of 0, which when added together gives us a total area of 10. Therefore, we can approximate the integral from 0 to 4 of the function 4x minus x squared as about 10. Next up is left-hand sums. Now everything we learned with the right-hand sums applies to the left-hand sums, except that we're going to start using these 4 numbers instead. Starting at 0, the y value is 0. At 1, the y value is 3. At 2, the y value is 4. And at 3, the y value is 3. So now we can use the equation to find the area of each rectangle, which we can add together to find the approximated area under the curve. Now, after we've plugged in all our numbers, we find that the first rectangle has an area of 0, plus the second rectangle, which has an area of 3, the third rectangle has an area of 4, and the fourth rectangle has an area of 3. And when you add those all together, you get 10. And therefore, you can approximate the integral from 0 to 4 of the function 4x minus x squared as approximately 10. It's good to note that left-hand sums and right-hand sums will not always be equal. It just so happens that this function is symmetrical, so that's why that happens. As I'm sure you saw, as we were doing the left and right-hand sums, a lot of the rectangles had area inside and outside of the curve, which can make the approximation a little bit off. But the way to counter that is to do a midpoint sum. So the difference between a midpoint sum and a left or right-hand sum is instead of using these values, we're going to find the in-between values. For the first rectangle, we have to find the midpoint between 0 and 1, which is 1/2. For the second one, we have 3 halves in between 1 and 2. For the third one, we have 5 halves in between 2 and 3. And in the fourth one, we have 7 halves in between 3 and 4. And now, we can draw our rectangles. And now that we've done that, just like before, we can use our equation to find the area of each of these rectangles and then add them all up. Now, after plugging them all in, we can find that the first rectangle has an area of 1.75. The second rectangle has an area of 3.75. The third rectangle has an area of 3.75. And the last rectangle has an area of 1.75. And if we add all those together, we get 11. And therefore, we can approximate the integral from 0 to 4 of the function 4x minus x squared as 11. For an even better approximation, we can take the average of the values we got for the left sums, the right sums, and the midpoint sums, which gives us an answer of 32/3. Now, if we compare that to the actual answer of the integral, we find that they're equivalent. Try out this example for yourself. A good n value for this problem would be 3. Here's the solution for the right-hand sum. Here's the solution for the left-hand sum. Here's the solution for the midpoint sum. Now, if we take the average of the 3 methods, we get 9.25, which when compared to the actual answer of the integral, which is 9, that's a pretty good approximation. Now, here's some food for thought. How do you think changing the bounds of the integral would change the way we use Riemann sums? The difference here is now that we're going from 0 to 5, this little piece goes into the negatives. How do you think that would change the way we build our rectangles? That's all for today. Hope you enjoyed learning about Riemann sums.